So in this last video on binomial expansion, I'm going to really show you the value of using binomial theorem over Pascal's triangle. So this question, it comes up in the mocks quite a bit, and I think it's come up in exam papers themselves before, but if you can do this, then everything else is dead easy. So if you get your head around this, you've won binomial expansion. So find the coefficient of the term independent of x in the expansion. So independent of x means without x, right? So there's no x attached to it. Again, you're actually going to save yourself a lot of time if you take 2 minutes to sit and think about it before you start writing. If you start writing, you're gonna end up writing loads and loads and loads of expansions and terms before you actually get to the point. Take a minute, digest what that means. If it's independent of x, what has happened? So if I take a look at what we're dealing with an x and a 1 over x. And we know that in binomial that they'll end up being multiplied by each other. They'll end up being multiplied by 8 choose something. I know it's 8 because we're to the power of 8. And what I want to happen is I want these guys to have the same power so that they eliminate each other, or that they undo each other. That's what I want. Now, this is not the right pairing because the powers do not add up to 8. But what could I put them to the power of? That's what we need to think of. So I'm looking to split 8 into 2 powers, and those 2 powers are going to be 4 and 4. And I figured it out already. And then remember, the structure is really important. This is the OR, and that OR is also going to go down here. So then you're going to have 8 choose 4, and then you're going to have x to the 4, 1 all over x to the 4. So we just need to do in our calculators then 8 choose 4. So I'm going to do that now. Which is 70. So 8 choose 4 is 70. X to the 4 by 1 all over x to the 4. You can, just to show you where it comes from, you're going to have 70 x to the 4 multiply, you can put it over 1, multiply top by top, bottom by bottom, x to the 4. When you have x to the 4 on the top and x to the 4 on the bottom, they are going to undo each other. Or you could even, let me take a slower step. What happens when we have indices and we divide? We subtract the powers. So subtracting the powers, I'm left with x to the 0. Any number to the power of 0 is 1. So we're left with 70 by 1, which is just 70. And that's it. And I got there really quickly because I stopped and I thought about what it meant to be independent of x, what had to happen, what rules did I have to uphold when I wanted that to happen. So I wanted them to eliminate each other, or I wanted them to drop out. And the rule was that if I was putting them to the power of anything, both of those had to add up to 8. So it couldn't have been 1 and 1, it couldn't be 2 and 2, it couldn't be 3 and 3. Had to be 4 and 4 to get us our 8 up the top here. And that's it. There is another example we can do down here. The first part kind of gives you a clue. It says write out the general term form of the binomial expansion x squared minus 1 all over x. So the general term form we could write out, and that's going to allow us to do question 2, which is the one I want to focus on because I'm going to end up writing it out then anyway. It says hence or otherwise find the value of the term that is independent of x. If it's independent of x, it means that they're going to drop out. They're going to end up eliminating each other, right? So I need them to have the same powers. So let me write this. 15 choose something. I can say r for now. 15 choose r, it's going to be x squared to the n minus r. But remember, n is just what you have to the power of anyway. So it's going to be 15 minus r. I don't know what r is. I'm going to leave it for a second. And then it's minus 1 over x. Make sure you put the minus in the bracket to the power of r. Okay? So that's the general form term of that binomial expansion. If I was expanding it, I'd also have to put in, look, our r is equal to 0 and our 15. And if I was to get all of them, I'd need to have that in there. But I don't. want that. I don't need to do it all. I don't need to spend 15 minutes writing this out to get it out. If you spend 1 or 2 minutes at the start of the question really thinking about it and considering your strategies and what it means and what they're really asking you, you're going to save yourself a lot of time writing. So what has to happen is this x squared to the power of 15 minus r has to work out to be the same power as this when I put it out. So let me show you what I mean even clearer. That's 15 choose r. What I can do here is I can actually multiply that, because remember the indice rules or the index laws tell us that if I have a power raised to the power, I multiply. So that's actually going to be x to the 30 minus 2r. And this, when I have a fraction and I raise it to a power, the top gets raised to that power. So it's going to be minus 1 in brackets to the power of r, x to the power of r. Both of them, top and bottom, get raised to that power. Now, don't know what that is, but I do know I could multiply that out if I wish. So I would have x to the 30, let me make that clearer, x to the 30 minus 2r by minus 1 to the power of r all over x to the power of r. Now the goal here is that these two would be the same and be able to drop out, so they need to have the same powers. That's the goal. I want them to be gone so that I'll just have a term without any x's in it. So I'm going to say that in mathematical terms. I want the powers to be the same. And in maths, what do we say if they're the same? I say that they're equal. So I'm going to say that. I'm going to write that out. So I'm going to have that 30 minus 2r has to be the same as r. And now I'm going to solve that. So I'm going to add 2r to both sides. I get 3r. I'm left with 30 on this side. I'm going to divide both sides by 3 and I get r is equal to 10. So now I'm going to go back and I'm going to check, does that give me a term independent of x? And if so, what is that term? So I'm going to fill it in. 15 choose 10, which is something we'll be able to get in our calculators. I'm going to have 15 choose 10. I'm going to have x to the 30 minus 2r. So it's going to be 2 by 10. And then I'm going to have by minus 1 to the r, which is now 10, all over x to the r, which is going to be x to the power of 10. So let's break that down. 15 choose 10, you can put into your calculator and you'll get 3003. Working out the powers here, x to the 30 minus 2 by 10, that's going to be 30 minus 20, which is 10, minus 1 to the power of 10. Remember the trick. If it's to the power of an even number, that works out to be positive. So it's going to be positive 1 all over x to the 10. If you focus in on the indices here, the law is if you're dividing indices, you subtract the powers. So you're going to have 3003 x to the 0 by 1, x to the 0 or any number to the power of 0 is going to be 1. And then you're going to have 3003 by 1 by 1. So we're left with 3003. And that's as hard as they get. They could give you different numbers, they could give you different powers, but that is as difficult as it gets. So if you can get your head around that kind of a question, then you've figured out binomial.